Welcome to this talk on role of free and open source software in information and knowledge management. The talk will be based on the following 12 points, and I will begin with a brief introduction to free and open source software. In today's world, software is everywhere, ever present, and with the advent of mobile devices and the penetration of internet access to even the remotest of places, software determines quality of services we receive and in fact the entire quality of life. Many of the government and banking services on which our daily lives depend on software. Therefore, software plays an important role in every aspect of our life, including higher education. Therefore, it matters very much what type of software is good for the community as a whole. To look back at the history of computing, in the early years, hardware and software were bundled together as a single entity. Software was not sold separately as it is today. Computers came with the operating system and the application software, and in fact, most of the software was available in source code. In fact, it was a common practice to modify the operating system or the application software source code if it did not already do what the end user wished. It was a common practice to also share the improvements with others. No one objected to such a practice in the early years of computing. But things began to change with the appearance of portable operating systems such as Unix, which were able to work on different hardware. Gradually, by the late 1970s and early 1980s, companies began to see the important role software was going to play and began to move towards proprietary and closed source. Once personal computers became available by the mid 1980s, closed source software became more a rule rather than an exception. FOSS and indeed closed source software is used in many forms. Software may be operating systems for desktops and mobile devices. It could be server software to run web servers, storage servers, cloud servers, or it could be application software. And software are deployed in different forms. Software may be available as desktop applications or web applications or mobile applications. Popular FOSS, which are in wide use today, are worth noting. GNU Linux operating system for desktops and servers is almost the backbone of the internet today. The Android operating system for mobile devices contains the Linux kernel. Apache and Nginx web server software drive the entire internet services. Cloud management and containerization software such as Kubernetes, OpenStack, Eucalyptus, and Podman, RDBMs, relational database management systems like MySQL, PostgreSQL, programming languages such as Java, PHP, Python, and Ruby. All this goes to show that free and open source software, even today, drives the internet and information technology world. Most of the aforementioned software, unfortunately, runs only in the background and it is invisible, but an essential component of the internet. Without FOSS, there would be no internet. Without FOSS programming languages, many of the open source and closed source application software could not exist. Many of the services on the internet that we take for granted would not exist. Wikipedia, for example, is written in PHP. Many of the Google services use Python, whereas the Google software itself is closed source. FOSS programming languages are the foundation on which many startups are built. FOSS helps lower the cost of services such as cloud infrastructure, and a large number of desktop software are FOSS. LibreOffice is one example. Let us first take a look at what makes a software free and open source and what makes the software closed source. It is the license under which the software is distributed which determines whether it is FOSS or closed source. The word free in free and open source is a misunderstood term. Therefore, there is a proliferation of FOSS licenses, and therefore there is some amount of confusion amongst end users regarding what a FOSS license is. Irrespective of the FOSS license, there are four attributes which are common to all free and open source software licenses. First is the freedom to run the program as you wish and for any purpose without any restrictions. This is usually called the freedom zero. The second is the freedom to study how the program works and change it so that it meets your computing as you wish. This is called freedom 1. Third is the freedom to redistribute copies so you can help others. This is called freedom 2. And the fourth freedom is the freedom to distribute copies of your modified versions of the software to others, which is freedom 3. It must be noted that free in FOSS refers to freedom and not to cost. And freedom 1, that is the second freedom, freedom to study how the program works, requires access to the source code. Without the access to the source code, freedom number 1 would not be possible. If some frequently asked questions about FOSS would help clarify any ambiguity. To the question, does the word free in FOSS refer to cost? The answer is no, it refers to freedom. The question, can FOSS be sold for a price? The answer is yes, if the buyer is ready to pay for it. There is no restriction in the license which says that FOSS should be given free of cost. But source code must be disclosed. That is the license that is the condition that the license imposes. Whether you are paid for the software or not, it is not a part of the license, but the source code must be disclosed. Can FOSS be modified and used in private without distributing to others? The answer is yes. FOSS licenses do not enforce sharing of the customized version of a program. So if you have a free and open source software which you have modified for your own self, the license does not enforce that you should necessarily share it with others. There is no such clause in the licenses. What is the difference between free software and open source software? Are they the same? Free software emphasizes freedom, while open source emphasizes openness of the source code. They are different licenses, but essentially they assure the same freedoms. Let us take a look at the attributes of a free and open source software. What characteristics should we look at when we want to ensure whether a given software is free and open source or closed source? These would be some of the useful attributes. One, license and copyright notice. So, is a copy of the license required to be included? Second, private use. Can the program be used and modified in private? Commercial use. Can the program be used for commercial purposes? Distribution. Can the program be distributed to others? Can the program be modified? Does the license provide and express grant of patent rights from contributors? Should source code be disclosed when distributed? Is the program required to be redistributed under the same license as the original? Is it required to document changes made to the program? Does the license include a limitation of liability? Does the license provide any warranty to the user? And is use of certain trademarks associated with the program prohibited or permitted? So when you look at a free and open source software or even closed source software, these are the attributes you should consider, look at, and based on that, take a decision. Just to help you understand these aspects, I can make a comparison between two very popular free and open source software. The two which I will be comparing are the MIT license version 2 and the GNU GPL version 3. For example, you will see that both the software licenses grant the following permissions. Private use is permitted, commercial use is permitted, distribution is permitted, modification is permitted, and license and copyright notice must be included. All these are included in both the licenses. Warranty, there are no warranties assured by both the licenses. In fact, most of the free and open source software do not give any warranties, and both of them do not include any clauses regarding trademarks. And the liability on the software for any loss to the end user, it is limited. These are very common in almost all free and open source software. The three aspects where the two licenses differ are in the patent use and the disclosure of the source code and whether the same license is to be applied. For example, MIT license version 2 does not state anything about patent use. It does not state anything about disclosing the source code and does not state anything about whether the software to be redistributed should follow the same license. On the other hand, GNU GPL imposes certain conditions. It says it provides an express grant of patent use from contributors. It ensures that source code must be made available, and it also requires that the same license must be applied to any modifications made to the free and open source software. So you can see that most FOSS licenses are similar, but there may be minor variations. It is a good idea to check out these aspects for the software. Another aspect that many users find difficult to understand is how free and open source software make money. How do you earn money from FOSS? Can you earn money from FOSS? Is it possible? And you can see that there are different software which use different approach to making money, business models. But one thing is assured, that is, if the software is free and open source, whether you pay for it or you don't, the source code to the software must be made available to the end user. No matter what, this cannot be withheld. This is what distinguishes free and open source software from others. Some of the well-known free and open source software, some of which I have already listed, are the GNU Linux operating system, the Android operating system for mobile devices, Nginx and Apache, which are the dominant web servers with the share of 35% and 24% of the market respectively. PostgreSQL, MariaDB, and MySQL are the dominant relational database systems for web applications. Kubernetes, OpenStack, Eucalyptus, Ansible, and Puppet are the leading DevOps software, development operations software. GIMP is a free and open source software for image manipulation. Blender is a 3D modeling animation software for desktop computers. And LibreOffice is an office suite for desktop computers. Turning my attention to the use of free and open source software in information and knowledge management, I would like to touch upon 5 different types of software. They are the library management or the integrated library system, ILS, institutional repositories, IRs, enterprise content management, ECM, learning management systems, LMS, and optical character recognition, OCR technologies in archiving. These are critical components of information and knowledge management in higher education institutions. Let me first take the example of Koha, which is a well-known integrated library system. The word koha literally means gift in the Maori language of the indigenous people of New Zealand. It was created in 1999 by Katipu Communications for the Horawehuna Library Trust, and the first installation went live in 2000. From 2000 onwards, several companies started providing commercial support for Koha, and today the number of such companies is more than 50. They make improvements and customizations, and therefore, Koha today supports multiple languages and has features that are no less than commercial closed software for integrated library systems. You can see that the advantage of the free and open source software is that if any company makes an improvement or a customization, that improvement is available to all users of Koha, because the definition of free and open source software ensures that improvements made are given back to the community. Koha is an excellent example of how FOSS is a win-win proposition for all stakeholders, be it institutions, developers, or users. You can see that not only the institutions and the end users, even the developers benefit, because you can see that there are 50 companies who earn their revenue by customizing and improving Koha. And this also is a good example of how a free and open source software can sustain and grow over 2 decades and continue to remain free and open source. The second example is of institutional repositories, which offer a set of services to the members of an institution and sometimes even to the general public. The main purpose of institutional repositories is the management and dissemination of digital materials created by an institution and its community members. Digital materials may include monographs, e-prints of academic journal articles both before and after undergoing peer review, electronic theses and dissertations, datasets, course notes, learning objects, and conference proceedings. IRs drive the open access movement across the world and make knowledge easily accessible to all without any restrictions. The two popular institutional repository software from the free and open source software community are Dspace and Eprints. Taking a short look at these two software, Dspace was jointly developed by MIT and HP Labs in 2002. It was initially governed by the Dspace Federation, formed in 2004. It is currently governed by LISACON, which is an organization which is set up specifically for the purpose. And ePrints is a web application and command line software which was created in 2000. You can see that both of them are more than 2 decades old. It is written in ePrints actually is written in an open source language, Perl, and uses Apache as the web server and MySQL as the database. So you can see that these software in turn make use of other free and open source software. ePrints is currently maintained by a team at the University of Southampton, UK, and both these software play a critical role in supporting open access, which would not be possible for a closed source commercial software. The third category of software important for higher educational institutions is the enterprise content management, ECM. It includes several aspects such as document management and digital asset management. Document management deals with creation and management of documents, automating business process with workflows, and ensuring compliance to distribution, governance, and retention policies. Digital asset management helps in managing access to rich media and digital assets such as audio and video, which is quite common in many higher educational institutions. Other aspects of digital asset management may include optical character recognition technologies, which make scanned documents searchable, and categorization and tagging to make retrieval easy and painless. One free and open source software for enterprise content management is Noxio, which is a free and open source software for ECM. It is developed in the Java programming language with support for both SQL and NoSQL databases. Its source code and documentation are available to the public. The company, Noxio, earns its revenue from customizing the software for specific markets, such as claims management for the insurance industry and case management for health insurance industry. However, it can easily be used to manage digital assets of any other institution, such as higher education institutions and libraries. So you can see that this company could have easily not disclosed the source code and earned its revenue. But this company decided that the source code shall be made available to others. So this is one aspect of free and open source software, which helps the community as a whole. The fourth category of free and open source software for higher education institutions is the learning management system. Learning management is usually handled by information technology staff in collaboration with information management staff in most educational institutions. The abundance of information available to students, the method and approach to learning, this has changed over the years. Focus has shifted from providing information to one of mentoring students to discover information from multiple sources and convert that into knowledge. The role of a teacher has changed from one of provider of information to that of a coach and a mentor. Learning management software has a critical role to play in this process by setting goals and monitoring the progress of individual students and providing general and individual feedback. The free and open source software commonly used for learning management are Moodle, which is a well-known LMS. It is developed in a free and open source programming language, PHP, and uses the free and open source RDBMS MySQL. A second one is called Sakai project, based on the Java technology, and is a virtual learning environment, and is developed by a community of academic institutions and commercial organizations as well as individuals. And the third one, Open edX platform, is the open source software for edX MOOCs, which are so popular. This same software which drives the edX platform is available to anyone as a free and open source software for their individual use. Open edX platform is developed at MIT and Harvard. Each of these offer a rich set of features that rival commercial and closed source LMS such as Blackboard and Canvas LMS. And the last technology I want to touch upon is the optical character recognition, OCR. It is very critical to make scanned documents searchable. Without that, the scanned document would not be of as great a importance and use as when it is searchable. OCR technology has improved by leaps and bounds with improvements in the machine learning technology over the last decade. It is now possible to recognize scanned documents in several languages in addition to the English language. One software from the free and open source world is Tesseract. It is a leading OCR software originally developed by Hewlett Packard as a proprietary software in the 1980s and released as open source in 2005. Subsequent development of Tesseract has been sponsored by Google since 2006. It is written in C++. It can recognize 116 languages in both monospace and proportional fonts. It also has capacity for layout analysis and can recognize multi-column text, images, and equations. Moving to the last aspect of this talk, just because a free and open source software is available and the source code is available does not automatically guarantee that it is immediately usable. Using free and open source software requires an understanding and skill in the use of information technology, such as installing and configuring operating systems, libraries, packages, compilers, deployment of software to cloud infrastructure, etc. This can be done with collaboration amongst the information technology professionals and the information management professionals. Alternately, either information technology professionals must learn information management skills or vice versa. And to my mind, the reverse is easier. The second one is easier. End users can derive benefit from FOSS when it can be put to use for the benefit of all the stakeholders. Otherwise, the mere availability of FOSS is not worthwhile. Drawing to a conclusion, free and open source software plays a major role in making information and knowledge available to students and faculty. FOSS places an emphasis on a help your neighbor approach, which fosters a win-win proposal. Several FOSS have not only survived but thrived in spite of being free and free of cost, and have contributed to the field of information and knowledge management. FOSS has software for several aspects of information and knowledge management, which can be put to good use at higher education institutions. And for FOSS to be usable, information management professionals must become familiar with information technology and either learn the necessary skills or collaborate with information technology professionals. Thank you, and I come to the end of my talk.